Documentaries show black holes as simple cosmic vacuum cleaners. Textbooks describe them as dead stars that quietly swallowed themselves whole. Both versions are dangerously incomplete. The real physics is so strange that scientists argued for decades about whether to even publish it. Time stops. Information vanishes. The fundamental laws we trust break down completely. These aren't wild theories from science fiction writers. They're confirmed observations that challenge everything we thought we understood about reality. Subscribe to keep watching videos like this. Here are 20 facts about black holes that mainstream science communication left on the cutting room floor. Number 1. The smallest black hole ever discovered is only 12 miles across. That's smaller than Manhattan. Yet it contains more mass than our entire sun compressed into a space you could drive across in 15 minutes. Scientists at Ohio State University confirmed this in 2021. Here's what few people know. The gravitational pull at the surface is so extreme that light itself cannot escape. Not because light is slow, because space itself bends inward so sharply that every possible path leads back to the center. Number 2. Time near a black hole doesn't work the way you learned in school. Einstein predicted this in 1915, and GPS satellites prove it every single day. Clocks on those satellites run faster than clocks on Earth because they're farther from our planet's gravity. Now, multiply that effect by billions. Someone falling into a black hole would experience normal time passing, but from the outside, you'd watch them slow down, fade to red, and freeze at the edge forever. They'd never actually cross the boundary from your perspective. Number 3. Textbooks say black holes form when massive stars die. The truth is more complicated. Physicists now believe primordial black holes formed in the first second after the Big Bang. No star required. The early universe was so dense that random fluctuations created pockets heavy enough to collapse instantly. Some of these could be smaller than an atom. Others could be larger than galaxies. We haven't detected them directly yet, but their gravitational signatures appear in data from the Planck satellite. Number 4. Here's a fact that breaks most people's intuition. Supermassive black holes can be less dense than water. The one at the center of the Phoenix A galaxy contains about 100 billion solar masses. Spread across its enormous volume, the average density drops below what you'd find in Earth's atmosphere. You could theoretically float inside without being crushed. At least initially. The catch is that you'd still never escape. Density isn't what traps you, curved spacetime is. Number 5. In 2022, NASA released audio from a black hole for the first time. The Perseus cluster, 250 million light-years away, produces actual sound waves. Pressure ripples move through the hot gas surrounding the central black hole. The frequency is 57 octaves below middle C, far too low for human ears. Scientists pitched it up to make it audible. What you hear is the deepest note in the universe, playing continuously for millions of years. Number 6. What happens when you cross the event horizon? The answer is disturbing. Your body would stretch vertically and compress horizontally in a process scientists actually call spaghettification. The gravity at your feet becomes so much stronger than at your head that the difference tears you apart atom by atom. For a small black hole, this happens before you even reach the boundary. For a supermassive one, you might cross safely and only get shredded later, deeper inside. Number 7. Stephen Hawking lost a famous bet about black holes. In 1997, he wagered that information falling into a black hole was destroyed forever. This violated a fundamental law of quantum mechanics. By 2004, he conceded, information must somehow escape, though we still don't understand the mechanism. Physicists call this the information paradox, and resolving it might require rewriting physics itself. Number 8. Some theorists propose a firewall at the event horizon. Not a gentle boundary, but a wall of radiation that incinerates anything crossing it. This contradicts Einstein's equivalence principle, which says falling freely should feel like floating in empty space. The debate has split physicists for over a decade. Number 9. In 2015, LIGO detected gravitational waves for the first time. The source was two black holes colliding 1.3 billion light-years away. The merger released more energy in a fraction of a second than all the stars in the observable universe combined. That's right, more than every star everywhere all at once. Number 10. Black holes spin at nearly the speed of light. The fastest measured rotation belongs to a black hole in the Milky Way, spinning at 84% of light speed. Its edge moves at over 150,000 miles per second. Think about that. An object with the mass of millions of suns rotating nearly 1 billion times faster than Earth. Number 11. Every galaxy we've ever observed has a supermassive black hole at its center. Not some galaxies, every single one. The Milky Way is no exception. Ours is called Sagittarius A star, and it sits 26,000 light years from Earth. In 2022, the Event Horizon Telescope captured its image for the first time. Here's what few people know. You're orbiting it right now. The entire solar system revolves around this invisible monster at 500,000 miles per hour. Number 12. Einstein's equations allow for closed time-like curves. In plain language, that means paths through space-time that loop back to their own starting point. Time travel. Near a rotating black hole, these curves might actually exist. Physicist Kip Thorne demonstrated mathematically that wormholes stabilized near black holes could theoretically connect different moments in time. This isn't science fiction speculation. It's published physics that earned a Nobel Prize in 2017. Number 13. If black holes exist, white holes might too. A white hole is the theoretical opposite. Nothing can enter and everything must exit. Some cosmologists propose that every black hole in our universe connects to a white hole in another universe. The Big Bang itself might have been a white hole eruption. We have no direct evidence yet, but the math permits it. Number 14. The first image of Sagittarius A star revealed something unexpected. The black hole flickers. Its appearance changes on timescales of minutes as hot gas swirls around it at nearly light speed. Researchers had to combine thousands of images to produce a single, stable picture. The technical achievement required telescopes on 5 continents working simultaneously. Number 15. For decades, physicists believed black holes were perfectly simple objects described by only 3 properties: mass, spin, and electric charge. They called this the no-hair theorem. In 2021, researchers found evidence that black holes might have quantum hair after all. Additional information encoded on the event horizon. This discovery could finally resolve the information paradox that haunted Hawking for decades. Number 16. Black holes aren't permanent. Stephen Hawking proved in 1974 that they slowly evaporate by emitting radiation. The process is unimaginably slow. A black hole with the mass of our sun would take 10 to the power of 67 years to evaporate completely. That's longer than the current age of the universe multiplied by itself several times over. But eventually, every black hole will vanish. Number 17. What if the event horizon simply disappeared? Physicists call this nightmare scenario a naked singularity. The point of infinite density would be exposed directly to the universe. Cause and effect could break down. Roger Penrose proposed cosmic censorship, the idea that nature always hides singularities behind horizons. But mathematical solutions exist where naked singularities form. We just don't know if nature allows them. Number 18. Some theorists calculate that black holes are the most efficient computers possible. The information storage capacity of a black hole far exceeds anything we could ever build with conventional matter. A black hole the size of a proton could theoretically store more data than every computer on Earth combined. Number 19. Here's a thought that keeps cosmologists awake at night. What if our entire universe exists inside a black hole? The math works. Our observable universe could be the interior of a black hole that formed in a larger parent universe. We'd have no way to detect the boundary from inside. Some researchers argue this explains why the universe appears flat and why the Big Bang happened at all. Number 20. After everything scientists have discovered, the biggest questions remain unanswered. What actually happens at the singularity? Does information truly survive? Are there other universes on the other side? The honest answer is, we don't know. The most brilliant physicists alive are still arguing about fundamentals. Black holes aren't just objects in space. They're doorways to the limits of human knowledge. Every observation raises more questions than it answers. That's not frustrating. That's the point. The universe is stranger than we ever imagined, and we're only beginning to understand. Like, if you learned something, share if any of this shocked you. The real story of black holes is still being written.